Okay, good morning everyone. I heard from your teachers that this week you've been learning a little bit about space. And although I'm not a space specialist, I thought I can connect an event that has to do with space with something that I really love, which is paleontology. So I want to talk to you about dinosaurs because I know everybody loves dinosaurs. And so one of the theories to dinosaurs going extinct is that there was a huge asteroid, which is a piece of rock, or I guess sometimes the rocks are giant, like giant pieces that actually land on our planet and they cause a huge havoc. So they think that caused a chain reaction where the dinosaurs eventually died out, although one type of dinosaurs didn't die out, and I'll talk about that a little bit later. So I just want to show you some pictures going back to our planet about 66 million years ago. So 66 with like 6 zeros after it. That's a long time ago. People weren't there at that time, but they think that a giant asteroid struck the Earth's surface, and it's what we call the Yucatan Peninsula. So it's like in Central America. They think that's the spot that the giant asteroid hit 66 million years ago, and caused a huge hole because the asteroid coming in and hitting it at huge speed caused a giant hole in the ground, but also it spread out. It wasn't just the size of the asteroid, but the disturbance to the Earth was much, much greater. Huge areas were disturbed, as you can see by the ring created by the asteroid. And just to remember that 66 million years ago, the planet was not, like the continents were not at the same place as we find today. So that little dot right here is where that asteroid hit. But you could see that some of the continents look kind of different than what they're like today. So just to remember that in 66 million years ago, the continents were not the way that we're finding today. Anyway, so how do we know this? Well, there's a distinct line where before 66 million years ago, there were dinosaurs, and there's a thin line of, they call this K2 boundary. When you go to high school, you find out more about it, but there's this thin line of sediments that show a definite split between when the dinosaur fossils are found and when the dinosaur fossils are not found. So it means that they were no longer there. So that's how we know that the asteroid was hitting the Earth at that time. And again, this is something that you'll learn when you go to high school, but you can tell the time of this is the geological time. So this is like how old the Earth is and what kind of animals and plants you find in the fossil record. And the part that we're talking about is right here between the Mesozoic and Cenozoic era and the Cretaceous and Paleocenic time, so between 66 to 65 million years ago. And you could see different kinds of fossils. And you learn how to date this because some of these are very, very old. And just a quick way that something gets fossilized, for instance, not everything gets fossilized, but if you die and if you're quickly buried, because if you're dead and then if you lie around, sometimes the predators or decomposers, scavengers will eat you up. So you have to be quickly buried by mud or sand or different waste. And then the body basically gets replaced. Usually the soft parts don't get fossilized, but the hard parts do. They get replaced by the minerals. And then so you get pretty much a rock that you can unearth many, many years later. Anyways, some of the fossils I'm going to show you. One group of fossils that I'm going to show you is called the ammonite. And here's an ammonite here. I have one at home that's like half the size of this table. So ammonites are relatives of okay, I'm gonna hold it like this, squids and octopus, and they lived millions and millions and million years. They are extinct now, but you could see that the shell was coiled, and then the little tentacles came out, and they were able to float up and down the sea. Some ammonites became uncoiled. So here's a cast of what they call a heteromorph ammonite, and then it looks so beautiful the way it is, but like they were very big as well. Some of them, some are tiny, some are really, really huge. So that's one group of fossils that you might find. There's another group, of course, everybody loves the megalodon, right? The giant shark. And here's a medium-sized megalodon tooth, but some of them get big, like they can get double the size of this. And you can see how big a tooth is compared to how big a person is, right? So it's lucky that we weren't around when megalodon were swimming in the oceans, because they would be fierce. They could just swallow us up without even biting us. So you could see the size of the jaw there. Okay, another one that looks kind of cool are the trilobites, and these were like relatives of what we call arthropods. They look like bugs because they are relatives of bugs. They're relatives of horseshoe crabs and all kinds of, even insects. Here's a trilobite. It doesn't have that many features here, but some of them get very, very, I guess, detailed. So they live for many, many years. And then the last group I'm going to talk about are the crinoids. They kind of look like flowers, but in fact, they're relatives of starfish. So crinoids are very, very beautiful because when they're fossilized, you can see all the details. And what they used to do, and you can see it here, is that they have these feathery parts that they would use to trap particles of food. Okay, so what I'm going to do is show you not only the fossils, but I'm going to show you how you can make silicone molds and cast fossils. So I have the real fossils here, and what I did was, using the real fossils, I've made these silicone molds, and I'm going to show you how you can actually make these replicas or exact copies of what the real fossil look like. Okay, but before I do that, I know a lot of you guys are really special, really knowledgeable in dinosaurs and you love dinosaurs. So I just want to show you a fossil cast of a T-Rex toe or a claw. So imagine one of the toes of a T-Rex, and it's huge like this and very sharp. So that's why one of the reasons why they were like a good predator in those times. And then here's another. This was a tooth of a T-Rex. So they were also sharp, and they were serrated so that they could actually like cut they had little edges that they can cut their prey. And that's another T-Rex tooth. And then this is a Albertosaur tooth. Again, very, very sharp. So you can usually tell a predator from prey looking at their teeth and their claws, for instance. I was telling you earlier that the dinosaurs all did not go extinct. They think that the chain reaction from the asteroid hitting the Earth caused climate change, which eventually killed off the herbivory dinosaurs that are herbivores, and then that killed off the older or the carnivore dinosaurs, etc., etc. But one group of dinosaurs did not go extinct. Basically, the feathered dinosaurs. Today, we have the descendants, or the ones that came down from those are basically our birds. So birds are pretty much a living dinosaur, if you want to call it that. Anyway, so what I'm going to do is show you how to make these beautiful molds, casts. So what I'm going to do is show you what you need to do is get some plaster of Paris, and I got these packs of plaster of Paris from Home Hardware. I think you can go to any hardware store. And what you do is, they kind of look like flour, but you shouldn't be eating it because they're not good for you to eat and they harden. So I just take a little bit of plaster of Paris, and then what I do is I try to make it to the consistency of like pancake mix, okay? And you don't want any lumps because lumps are not good. They don't dry evenly, so you can try to take all the lumps out, and looks like this is a little bit too watery. So I'm gonna add more plaster. So it's just sort of, you know, trying and seeing. Whoa. Oop. Again, science is very messy. So after you mix it up pretty good, make sure there are no lumps. What you can do is you can pour it into the actual mold, and then it's gonna come up. So what I did was, when I made this mold, in the silicone, I put my shark tooth, the megalodon tooth, like that. So after the mold was finished, I pulled my tooth away and it left an impression just like that. So I'm gonna pour my plaster, and then what I wanna do is I wanna tap it so that there's no air bubbles. Because if you have air bubbles, then it doesn't look as good as the real thing. So you can let this sit for overnight, and then after you get your plaster out, what you can do is you can use acrylic paint, any type of paint really, and then you can see, you know, what color you want to make your cast. So you could do some art, you could do you know, realistic colors that you might think what a dinosaur claw might have looked like, because nobody really knows the actual colors of some of these, but I mean, usually claws are kind of dark gray, etc. Or you can go fanciful and make it into a giant pink ammonite if you want, right? So you could do this. If you have any, I'm gonna make another video on fossils next week, because this is what I like to study and what I like to collect and have around me, because they are very interesting to me to study the Earth's history. But if you want any of these for yourself to paint and stuff, let me know, because I do have some extras that I can make for you if you like a megalodon tooth cast or a trilobite or an ammonite. Let me know. Okay, so that's it for today. So we'll talk to you soon. Bye.